Hello everybody. So in this video we're gonna talk about the second type of columns of the shortcut columns, which is the ISTL column, which is used for as it's mentioned here for the shortcut distillation rating. So what we're gonna do is first we're gonna connect the column with the products and with the input, and let's see, I just want to get everything named well, so I'm gonna call it F short 2 to differentiate this from F short 1 for the design mode column, and this is gonna be called short 2. This is gonna be short 2T for top, and this is gonna be short 2B for bottom. So regarding the connections, I have everything connected to the column from the feed and from the product. Um, Before we go ahead and see how we're gonna deal with the column, the inputs and the outputs, you just need to keep in mind that this is a design mode column. I mean a rating mode column, which means that the inputs and outputs are different. So in this case, I had to define the desired outputs. In this case, I defined the recovery in the top section, or in the top product of the two light and heavy key components, and I define the pressures, and I define different things that I want to achieve, and that's why the outputs were the reflux ratio, the number of stages, and all these things. But in this column, I'm doing I'm doing the calculations the other way. So I'm defining the specifications of the column, and I'm getting the outputs that are coming due to this inputs. So what I'm gonna do is I'm giving the outputs of this column to this column, so that we can kind of know that they should, or what kind of output that we should expect, and to see what we have in this column. So if we open this column, we will see that it's asking for the column specs, which are the number of stages, the feed stages, the reflux ratio, the distillate to feed molar ratio, the condenser type, and the pressures. If we take a look at the outputs of the column short 1, from the result summary, we will see that we have all this information here. So I have here the number of actual stages, the feed stage, I have the number of stages before the feed stage, so I have everything here, and I have the distillate to feed fraction. So these are the inputs that I'm gonna give to this column. So for the number of stages, I had the number of stages here. Let's open them together so we can easily go from here to there. No, I need this. So I have the number of stages. So this is 40.8, so I cannot put fractions here because this should be the number of actual stages. So this has to be a number. So if I put 40.8, so it's not allowed to put a dot. So I'm gonna go for one more stage, the feed stage. It was here 18.3. So again, if I go here, you'd see that these buttons for the arrows top and bottom mean that they have to be a whole number. So I'm gonna go for 18. The reflux ratio that we used was 6, so I'm gonna keep it as 6. The distillate to feed molar ratios was 0.5857, so I'm gonna put 0.5857. And regarding the pressures, I had information about the pressures. It was in the input actually. I defined this in the previous case, so it was 45 and 105 torrs. For the condenser 45, and for the reboiler 105 torrs. So this is all what I need to define, and it's already fully defined. Regarding the conversions, it's talking about the valid phases and the number of iterations, so it's not something that I need to worry about. So I'm gonna run the simulation, and it's now generating results. We don't have any errors, so everything is fine. But just you, before taking a look at the results, I want you to keep in mind that the method that this column is using, which is the administer method, it's a shortcut method anyways. So it's gonna do the calculations in a different way than it was done here in the Gilliland Underwood column. So the different methods of calculation and being working with shortcut methods which are not very accurate means that we should expect some difference between the outputs from here and there. It's not going to be a big difference, but there should be a difference between the two methods because they are doing the calculations by two different ways. So this has to be in your mind, so you don't feel that there's something wrong. This is totally normal. So if I go to the results here, I can see that the results are the duties for the condenser and the boiler, the feed stage temperature, the bottom stage temperature, and the feed quality. So these are just some information about the temperatures and the duties. So it's not something new. Now let's go and see the stream results, and this is the part where I am more interested in. So to feel the difference between the outputs of the two columns, I'm gonna put the outputs side by side. So it's the short to top, or let's put one first. The short top. This is the rating. I mean the design, and the short to top. This is the rating. Then short to or short one bottom and short to bottom. So this is the top product of the design mode. This is the bottom product of the design mode. This is the top product of the rating mode, and this is the bottom product of the rating mode. So I'm putting them side by side just to see the differences easily. Regarding the mole flows, it seems that they are not very different. Might be some differences, but not a lot of differences. For the mass flow, there is some difference. It's not a big difference, but it's more obvious than the mole flows, which tells that the molar composition is not the same for for the two streams. So here I can see that the flow rate of the ethyl benzene in the product is 150. Here is 148. In the bottom product is 1.2, and here is 2.95. So it's almost double, or it's not almost, it's more than double. Here it's 2.7, here 4.4, 106 is here 1.5. When we go for the mole fractions, we'll see that there is like easier to notice difference. So it's 1.1%. Here it's 2.7%. This is 9.8, or 98. This is 97. 1.8%. It's 2.9%. So there is some change in the compositions and the flow rates due to, again, the difference in the method of calculation. And here comes the question, which will definitely you're thinking of now, which is which one of them is right. So the answer is both are okay, because we know that we are dealing with shortcut methods, and we never get our results from the shortcut columns. The shortcut columns are a first stage before going to the rigorous columns. It's good to get or use them if you want to get some estimates, and in this case I believe the estimates are still valid in both cases, because either you go for this and this, they are very close, in the sense of having estimates. But if you want to get accurate data, you can never rely on this or on the data or the rating or on the design shortcut methods. So you have to go for the rigorous methods, which are the accurate tray-to-tray calculation methods. And by doing this, you can get extremely reliable results out of the column. So again, these are estimates. They are good to give you the values that you can give to the rigorous method column, so that you can get more accurate results easier, without like going for many trials with different numbers, without having any clear or close estimate to what you need to use. So this is all for this video, and in the next video, inshallah, we are gonna go for the red frac, which is the the rigorous distillation column, and we will see how we can use these values or these results here to run the other column. So I'll see you then inshallah. Goodbye.